So we're coming off of section 2. Section 2 that we did yesterday was all about lines. And so all the equations were for lines. All the graphs you did should have been a line. This section here we're doing quadratic functions. So it's going to be something different than yesterday, but they should all be the same as each other. So first thing is just kind of like, what's a quadratic function? So if we have a quadratic function, a quadratic, what is it? That's simply an equation where the highest power of x is 2. So equation where the highest power of x is 2. In other words, there has to be some sort of an x squared there in the equation. So I'm going to write down a couple different examples. You could write them down, you could skip them, but I think it might help it make sense. This here is going to be probably the most simple quadratic, would just be like a y equals x squared. Technically, you could say if you wanted to, y equals 1x squared for something like that. Another one would be y equals 3x squared minus 4. So you could have a certain number of x squareds. That 3 is called the x squared coefficient. That's what x squared is multiplied by. 4 is a constant kind of hanging out at the end. Or you could, if you wanted to, a third example would be something like a y equals negative 2x squared plus 7x minus 8 or something, or maybe a plus 8. But the key is you have to have an x squared, and you can't have something higher than an x squared. You can't have an x to the third or something like that. Feel like you know enough to be dangerous? Okay. Then no, unfortunately that's not it. I mean, fortunately there's more exciting learning that gets to take place. The shape. Often for the shape of these, they refer to them not as quadratics or quadratic functions. They refer to them as a parabola. So parabola. So all of the graphs that we're doing are going to be graphs of parabolas. And for those, essentially it looks like a U or a lowercase n. So it could be like really wide like this and open upward. Going to mess up the left side a little bit, but kind of like a U that opens upward. So it could be wide. It could be skinny. So I'm going to do another one that's skinny, but a skinny one that opens down. But you could have a skinny one that opens up, or a wide one that opens down. But the two things that are going to be true about all these graphs, one, it should be symmetrical. If you take that lowest point or that highest point and kind of do like a vertical line through it, if I would have drawn them correctly, you should be able to take and kind of fold the page and have the left side of that fold and lay right on top of the right side of it. That they should be lined up. And my one on the left looks particularly bad, the wide one. But they should be symmetrical if drawn right. Graphing calculators will make them look right. The other thing is it's going to open up. So opens up or down. That if you have something that's more like C-shaped, kind of like opening up to the side, something like that, that's not a parabola. It's not a quadratic. All right, up to there? Now graphing it. So I want to do an example. In my example, I'm going to say I want you to graph. So example, graph y equals 3x squared. So y equals 3x squared. And a lot of you are holding on to graphing calculators right now. The issue that I have is a lot of times people that use graphing calculators on the quiz or on the test, they get it wrong. And it's because what they do is they, first of all, and this is what I do if I were you, if you hit in the very upper left button, you have a y equals. If you press that, it should give you a list of like y1, y2, y3, and so on. If something's in there right now other than what we have, maybe just go to it and hit clear. But after y1, I'd say hit y equals 3x squared. And for this x value, you should have a button. If you go to your second button, then down one and right one, it should be like an x, comma t, comma theta, comma n, something like that. Now here's the problem, is people go through, once they type that in, very upper right, they have a button that says graph. If you hit that button, it'll show you the general shape of this, but your chances of getting that shape onto a piece of graph paper on a quiz or a test and have the points actually be in the right spot are pretty small. So what I would encourage you to do instead is up above graph it says table, and probably like either a blue or a yellow. Pick that table option. So if you press the second key and then that graph button, it should from there go through and give you a list of x values and y values. So you'll probably have like a a table that says like x and then a y1, probably a y2, and then list a whole bunch of x's and y's. Good? If you don't have that, or you're trying to do it the old-fashioned way, we could just pick some x values, put them in, and find y. So if I put a 0 in for x, 0 squared, 0 times 0 is?
0.
3 times 0? 0. So I know now that the point 0, 0 is going to be part of my parabola. Good? And now if I put in a 1 for x, I have 1 squared, 1. 3 times 1 is 3. So when x is 1, my y value is going to be 3. When x is 2, now I have 3 times 2 squared gives me, so 2 squared is 4, so 3 times 4 gives me 12. And if you're using the data table, those should all appear in there. You can use your up or down arrows to scroll up or down. All right. To make my graph turn out okay, I'm going to go up by 2. So we'll say that this is 2, and then I have 4, 6, 8, 10, 12, so 12. And to kind of spread it out, I'm going to go over by halves. So over 2 is going to be 1, over 4 is going to be 2. So now to actually go through and graph this thing then, so I had a spot at the origin. I have a 1, 3, so that's going to be right there. And then I have a 2, 12, that's going to be right there. Still tracking with me? So you could use your graphing calculator and the table function to get that. Now you want to try to do kind of like a smooth curve through those points. So something like this. Now, your options to keep going would be to go through and try some other points or look at your data table for other points. But nice part about parabolas is they're always symmetrical. So you could either say, oh, when x was 1, my point right here, y was 3, so I know when x is negative 1, y is also going to be 3. When x is negative 2, y is also going to be 12. Or you could just do the same thing on your graph and say, all right, I had this point here, it's going to be symmetrical about the y-axis. My other point's going to be right there. This point here is going to be symmetrical about the y-axis and show up right there. So you could use that whole symmetry if you wanted to find those points. But either way, you end up with a point right here. So I have my negative 1 there, so it would be right there. And 2, 4 would be another one. And try to do like a smooth curve through those. So something like that there. And ideally my parabola would actually come right down and hit the x-axis. I'm a little off there. You feel okay on those? So graphing, please don't just hit the graph button, look at the shape, and slap it on there. It's hard to get the right points. All right. Want to go through, and for this next part, I'm just going to kind of draw the general shape. I wouldn't bother drawing them. If you want to kind of punch them in the calculator, you can. We want to look at how does changing some different things about the equation impact the equation. So we just did a y equals 3x squared. So I'm going to leave that in as y1, and we had a shape that looked something like, ooh, it's perhaps a little on the wide side, so something like this here. So that'd be like my y equals 3x squared, a real bad version of it. If we were to have our second one be y equals x squared, so if where you have like a y2, so hit your y equals button, under the y2, type in x squared. If you hit graph, what do you notice about that next graph? The green one should be, so maybe I'll redo my blue one because that's really kind of, doesn't look like what you see on the screen at all. So my blue is maybe more like this. The green one, somebody said, is wider. So changing that number in front of x, the x squared coefficient, is going to impact how wide or narrow the parabola is. So I would write this down if I were you. I'm going to put it in red for dramatic emphasis, make it kind of big. So our generic form, later on they'll change the letters on you a little bit, but I'm going to say it's y equals ax squared plus k. Later they'll use a different letter for that k. But when we're looking at this a, first I want to say that's the x squared coefficient. A coefficient is just a number in front of a variable. A is the number in front of x squared, so it's the x squared coefficient. So what that does is it impacts how wide or narrow. So how wide or narrow the parabola is. And if you want to say a little bit more than that, you could say, when we look at this, the wider parabola was where we had y equals x squared. If we had to squeeze a number in front of x squared right there, what number could you put in there? Not a 2, that would change it. What number is kind of like there, but we didn't have to write it?
0.
Not a 0, because 0 times x would drop out 1. Yep. So it's kind of like y equals x squared is the same as y equals 1 times x squared. You agree 1 times something doesn't change its value? So when x is 1, it's wide. When x is 3, it's narrow. So kind of the rule of thumb would be x close to 0 is going to give you, I'm going to say, equals wide. If you have an x far from 0, the 3 is farther from 0 than the 1 was, it's going to be narrower. If we had like a y equals 7x squared or a y equals 1,000,000 x squared, that's going to be even narrower still. Tracking with me up to there? All right, if we take now and jump back to your graphing calculator, and I'll have that screen up again in a second. If we erase that y equals 1x squared, and instead let's change it to, or erase the y equals x squared, instead let's change it to y equals negative x squared. Or if you wanted to, you actually could type a -1 and then your x squared. But negative x squared or negative 1x squared. And then if you hit graph, so it opens down, and it's still wider, agreed? So it should be that same width as what we had before, because it's a -1 instead of a 1. It's the same distance from 0. But it opens down. So whenever you have a negative x squared coefficient, it's going to open down. So I'd write this here. I'd say if you have a positive a, it opens up. Positive people, what do you usually see on their face?
Smile.
A smile. So you can try to remember positive people. Parabola opens up. Negative people, frown. So if you have a negative a, that's going to open down. Or opens down. And so negative a is going to be something like that. It opens down.
So like the y equals.
So I'll give you a second to copy that. One last thing. Last thing is we want to look at how does putting a number at the end impact something. So why don't we flip back here, then you can copy all that down at the end in a sec. So my blue one is y equals 3x squared. Let's have our second one be the same exact thing, so y equals 3x squared. But now let's do a plus 4 at the end. So without the plus 4, we'd get the exact same as what I have there with the blue. So the plus 4. Before you do this even, maybe say this. Do you agree? This is going to give us the exact same as what's drawn, right? So we take x, we put it in and do something to it. When you add 4 to that, what's that going to do to the y value? It's going to make the y value 4 higher than just this part right there, agreed? So what should happen to this blue parabola when we graph that green thing? I guess punch it in and try it. So if you punch it in y equals 3x squared plus 4, what should happen is 1, 2, 3, 4. All the points, all the y values are now going to be 4 bigger. So if I have like 1, 2, 3, 4. So you could take each of these points and slide each point straight up 4. And that should give you your new parabola. So the new parabola should look just like that blue one, but it should be shifted up 4. That's a piece of art there, isn't it? Let's just quick switch screens. All right, so then the very last thing here with this plus k is you could say this here, the constant is officially what it's called, because it doesn't depend on an x. That number there will be a constant. And that's the height of the vertex. So height of the vertex. And I'll flip back to the screen in just a second. But the vertex is going to be this point right here. The point where it shifts from going down to switching back up. So the vertex will always be the very lowest spot on a parabola that opens upward. Or if I have a parabola that opens down, the vertex will be that very top part, the maximum. So the constant is the height of the vertex, and you could, if you wanted to, call it the turning point. And that's all the notes for today.